out here in my backyard. My backyard has changed quite a bit over the last few weeks. I haven't been posting any videos because I've been doing a lot of actual landscaping and kind of trying to prepare the backyard to be able to do more of this kind of content. So I'm here with the Dwarf Lab 3. It comes in this nice little case, and I'm just going to be getting it set up for the first time under the night sky in the backyard. I've had it out a few times. I had it out on a vacation that I took a few weeks back, and I put it through its paces, but tonight will be my first night under the night sky here in the backyard. And I'm just going to use a little tripod that I have for my phone to support this and give it some stabilization, level it out a little bit. For the most part, it doesn't take much to get this thing set up. There's a single button here on the side that you push, and it fires right up. And now it says make sure that you have a path to the night sky where it can see the stars, which is that way for me. Next, we fire up the Dwarf Lab app and we hit the connect button. And it finds the device and we log in. Now here's one of the things that I like about this app is that it provides you the ability to not only have the device working off of your Wi-Fi from in the device, but you can also connect it, as many other devices can, to your home network. And I'm going to join. It says there's a mandatory update that I have to do. This is new. Hopefully it doesn't take very long. All right, now that I've downloaded the upgrade, after connecting to my home Wi-Fi, I'm reconnecting back to the device, and it's going to perform the upgrade. All right, it's now asking me to do a reboot of the Dwarf Lab 3, and we're on to the next step. Now I want to mention before we go too far here that the conditions tonight are not ideal. We're dealing with some Canadian wildfires, and so when we go to Astrospheric, although it appears that we have really nice clear skies, when you go to the tab for the wildfires, you know that's not really what you want to be seeing. And so I wanted to just preface this, performance that you see out of the Dwarf Lab 3. It is in clear skies, but it is not ideal conditions. And this is the nature of doing, amateur astronomy in general. You're within the Earth's atmosphere, so not only are you dealing with weather conditions, but now with these wildfires becoming more common, we're dealing with that as well. So just a preface, a little caveat here before we see the performance. So I'm reconnecting to the device. It's now restarted. Okay, and we are connected to the Dwarf Lab 3. So I'm just going to go into the photo mode. And as soon as you go into photo mode, there are two separate cameras on this device. The first is the main imaging camera, which is what you would do for doing traditional, telescopic observations, some traditional astrophotography. But it also has a smaller camera that is capable of doing like Milky Way photography as well. It's a wide field camera, similar to what you might have on a smartphone. Let's do some astrophotography. So when you're in the Astro mode, of course you have the option to search. I'm going to go into the Atlas, and let's just take a quick look around and see if there's anything of interest that we would like to look at tonight. All right, now it is summertime, and one of my favorite things to do here in the summer is to take a look at this central point around Cygnus. Now I choose this because it has some bright stars within the field of view, as well as some dust and gases, dark nebulae, emission nebulae, and this is going to make it a little more challenging for the device to be able to handle that extreme, because you have the bright stars as well as the nebulosity. So let's try this out and see how it does. To point this to the sky. All right, it's taking a look, and it's moving its optics towards the sky now. Calibrating, looking for its position to do what's called a plate solve. So what this means is it's just looking at the pattern of stars in the night sky, and it's trying to connect that to a database that allows it to understand what it's looking at, and then it takes a number of images as it turns here to determine its position relative to the night sky. It's also including GPS, a compass, and all sorts of different techniques to make sure that it's viewing the correct position. I'm going to show you this. It's a mistake. Cygnus is actually right over a tree facing towards my camera here, towards the red light that you're looking at. And you can kind of make it out on the screen. Not the best position yet. If I gave it a few hours, this is actually facing towards the east, and so this is going to be rising over the next 20 or 30 minutes, and it'll be above the tree, and then I can image it. So let's focus on this side of the sky where I have nice clear open skies. Let's go around the handle of the Big Dipper. This is an easy one, actually. And right here at the handle of the Big Dipper are a number of objects. And of course, one of my favorite, M51, the Whirlpool Galaxy. This is actually a really nice target. It's a little small for the optics here to zoom in completely, but we can always crop in later and look at it that way. Do I want to stop and switch to tracking M51? Yes, I do. And now it's going to calibrate once again. It is very hot out here, guys. It's in the 90s throughout the day today. It was 89 degrees at about 7:30 p.m. It's probably in the mid to high 80s right now, and very humid. So forgive me here as I sweat. That moisture in the atmosphere, that heat, those thermals also play a role in how good of an image you're going to get. Seeing conditions, the thermal activity in the atmosphere, the moisture in the atmosphere, they all cause various different ways to obstruct and damage your ability to look at the night sky. So something to consider as we are doing this. Now I noticed as I'm talking here that it actually just failed in its position. Now there could be a number of reasons why that happened. I do have a very bright red light right here, but I'm going to give it a retry without changing anything and just see if it can figure it out on its own. And I'll try to stay out of its way as well. Now I do have a few trees around me here, but I do have a decent amount of open sky. It should have no issue trying to find it. It's doing quite a bit of turning around up and down, left and right. I don't know why it doesn't, oh, there we go. Now it should be able to find its position. All right, go to processing. It's currently 10 p.m. It says it's successful. All right, that's great. So I don't know what happened that first run through, but it's fixed it. We are now looking towards the Big Dipper. So let's see if I can give you a good visual there on that. It says it is in fact tracking. Now I'm allowing this to show you the full sky right now. This is the Big Dipper's handle that you can see right here, and I'm just giving you a basic understanding of where you're looking in the night sky. This is using the wide field camera, which is kind of nice to confirm that what you're seeing here matches what you should be seeing in the Atlas function. So it looks correct, and on this longer exposure I can see that. Press long to stop, and it's stopping that image. Not bad. I like that. I can use that wider field part of the camera to do what I just did. Confirmation I'm looking where I'm supposed to be looking. And you'll also see I'm getting a decent amount of stars here. I didn't let it go that long, only a few seconds. And it looks pretty good. So I'm going to enhance that image. Not bad. There's that image. That's amazing. I really cannot believe the amount of stars that I'm already seeing through there with just a few seconds. So it's impressing me with just that. And you can see it matches as it should with the Atlas for our object, which once again, it's right here. So the next thing we're going to do, here's basically what that image looked like. So the next thing we're going to do is we're going to take a longer exposure this time with the zoomed in camera. So it's doing an initialization right now. And once it locks onto this target, I'm going to just walk away for a few minutes, allow it to gather some data, and I'll do a quick time lapse over the course of the minutes that I allow it to go, maybe 10 or 15 minutes, to collect enough light to give us a nice image. And then I will come back on and we'll talk about it. So target is M51. It automatically chose a shutter speed of 15 seconds with a gain of 60. Says it'll do a total of 999 of these, and it gives me how many current have been taken and then how many have been stacked. Okay, so for those of you who are new to this, the target, of course, is the Whirlpool Galaxy M51. Shutter speed, 15 seconds is just how long each of these exposures the camera is taking are going to be, and you can already make out some faint fuzziness with that first image. And then as we look at the gain is just how much the sensor's sensitivity is. It's kind of like ISO if you're familiar with a mirrorless camera. It's a little bit different, but then the total number is how many images are we going to take, up to 999. I can stop that at any time. It's taken currently 3 of them, and it stacks them. So what it does is it compares one image compared to the other, and then it subtracts what is different between the images and keeps what is the same. And it does this over and over and over again. And there's a number of different reasons why there might be something in one image but not in another. It could be noise within your camera, which is common. It could be a satellite passing through your image, or a firefly for that matter that flies through here in my backyard. It could be a cloud passes through. For whatever reason, one image might be different than the vast majority of the rest. And so what it's doing is it's subtracting out all of the bad stuff and keeping all of the good stuff, and then it adds those up over time. It increases the signal to noise ratio, giving us more signal, gives us a better image, and the noise goes away. This increasing the signal to noise denominator ratio. And as this stacks, it'll get better and better. It's currently at 7 of them, and I'm going to stop talking. I'm going to walk away, and I'll come back in 15 or so minutes, and we'll talk more about what image it produces. Let's check it out then. Okay, it's a few minutes later and we are now at 57 total images that have been taken, and 57 of these images have actually been stacked. So it's using all of the data. I am looking up at the night sky right now and I'm noticing quite clearly that the sky is getting worse, not better, which for me that indicates that it's time to stop. And so I press and hold on the stop button here, and I'm going to end this M51 session of imaging with a total of 59 total images taken, and 58 of them are being stacked. And that's going to give us a good understanding of what can happen during what would be a traditional outreach event where you're spending 10, 15, maybe 20 minutes at the most on a particular object before moving on. And I see this as a great way to do outreach. It also could be used to, just entertain guests or kids. The app is easy enough that I think pretty much anybody who has the capability of using a tablet or a smartphone is capable of figuring out. It's very straightforward, it's very intuitive. The settings are all handled automatically, but they can be modified by you individually if you want to dig into the minutia of how long the exposures are. If you want to go to an equatorial mode where this is tracking in an equatorial fashion rather than the alt-azimuth mount system that I have, where you are oriented with the North Pole of the Earth, which gives you a longer tracking period. That is possible on this. It has the AI enhanced imaging, so I'm going to just do that and we'll see what we get. Not bad, not bad. It's a little bit fuzzy, pixelated, but it's also a fairly small object compared to our optics here. So, it's not taking up the vast majority of the frame of this particular sensor with this focal length. And so it's a challenging object as a result. We also didn't do a very long exposure. I'm under light polluted skies. I'm by no means in dark skies. And the conditions, as I said earlier, are not ideal. And so for all of those factors being considered, I think this is a pretty nice result. It's by no means an Astro bin of picture of the day. It's certainly not an APOD, but it's definitely an image that might get somebody excited who's just getting started. And like I said, especially kids who are interested in this, that are running it themselves. So that being said, looking at the night sky, I'm seeing it is getting a little bit worse in that direction. But Cygnus, that I had mentioned earlier, is now high enough. So let's take a look back at Cygnus. That's the challenging one I mentioned earlier. We'll go to the Atlas. We'll find Cygnus the Swan. And we'll go right to the center of Cygnus here, Sadr, and this dark nebula and emission nebula. That will be our target. Yes, we're going to go to the next object and we're going to let it calibrate. All right, so it appears that we have actually now focused in on the portion of the sky near Cygnus. This portion of the sky, as I said earlier, is very challenging. Let's take a look at what our image looks like. Now you'll notice that you saw motion here, me touching the table. Look at the star squiggling around on the screen. So be careful that when you're around this, that you're not making motion that's unnecessary. Try to make sure it's on a stable thing. This is on just a table, probably not the most stable of platforms. If you're gonna be on something like this, you wanna be careful that you're not walking around it. Even just stomping around can make a difference. Gotta love my trains. All right, now that the train has stopped blowing its horn, I'm gonna take a long exposure now, once again, of the wide field, just to get a position in the sky where our main camera is located. The little box in the center is the zoomed in telescopic one, that's this guy here, and this is the wide field camera on the other side. So let's do the wide field image first. And we're gonna take a wide field image. You can see the tree there in the foreground still, but we now, on the telescopic view, should be able to see over the top of that tree at the correct position in the sky. I do want to look for that bright star, Sadr, I believe is how it's pronounced, and I want to make sure it's within that little green box in the middle. Okay, this is not a great result. It did not stack any of the images. I'm not sure it is facing this red light here, so I'm going to try turning that off and see if that makes a difference. But you're going to not be able to see me anymore. Not the best results on that one. So I've moved my position of my camera behind the Dwarf Lab 3. That way I'm not interfering with the actual optics with the light source, hoping that that makes enough of a difference and allows us to see what we'd like to see in this part of the sky. Looking up there right now, it does appear to be clear, so let's give it a shot. So we've got our first image, and I am noticing that we do in fact have Sadr, the bright star in Cygnus, right there on the sensor. It is, as I had suspected, going to be very bright, but as you can see, there are a number of other stars that are definitely visible around it, like tons of other stars that are definitely visible around it. We're stacking 4 images so far, and it is going to start to clean up after a little bit here. 15 seconds per image, as it has been doing. I want to stop this real quickly and mention something that was not discussed earlier at this point, and that is the focus. So I had not changed the focus on this at this point, and I think it's important that I take a look at that and ensure that we're in the best focus possible. I think it does a pretty good job by itself, but we want to make sure that we're following through with everything as we go through this review. I will say I'm starting to see some nebulosity already at 9 images in, which is pretty impressive. I'm starting to see some pink down bottom there. Let's just enhance our image here real quick. Yep, definitely seeing some nebulosity already in the image. But I definitely want to make sure I'm doing due diligence here and we provide a focus here on this image. Okay, so I think it was definitely out of focus slightly. Now I'm at a different focus than I was before, and I am seeing that the smaller stars are more pinpoint, the bigger star is taking up less of a blob, and I think that that will make quite a bit of difference in my overall image quality moving forward. So let's go back now, and we're going to restart that run. I can change some parameters here. I am going to allow it to do the auto parameter. Auto mode sets the exposure and sets up everything as it needs to, or I can change the settings on my own. At this point, I think it's easier to just kind of show it in its native format, and we'll go from there. Now, I have not yet taken darks with this. That's something that I would like to do, but I just got this out of the box. I want to use it. All right, now that with this new camera angle, you can start to make out some of the really bright stars that are just above the tree line here. And that's where the Dwarf Lab, which is now right there, is pointing towards. And so as we are looking up there, you're starting to see on the image that we're getting a number of stars being stacked. Look at how pinpoint some of the smaller stars are. And the big star is, Sadr, is kind of becoming a little bit more blurred and takes up quite a bit of sensor space on its own because of how bright it is. It's actually leaking into the surrounding pixels and causing them to have brightness that's from the star, not necessarily from the background. Now, once again, I've chosen this part of the sky so that we can identify how it handles dark and bright objects all at the same time. All right, so what I'm going to do is I'm going to leave this go for 10, 15, 20 minutes, and I'll be back with the results. We're now at about half an hour into the imaging. It's starting to get clouded out above me, so this is going to be it for the evening. But I think overall the image that I'm getting off of the device, the Dwarf Lab 3 here, is pretty impressive given the current conditions and the fact that we only have about half an hour's worth of data. It's not even running in an EQ mode, and I haven't even done my dark frames at this point. So we have about half an hour's worth of data, and what I'm going to do now is click on the Enhance Your Image. Keep in mind, all of the original data is also being stored on the device. So if you want those raw files, those FITS files, you can pull them off and you can process them yourself, or you can just use what's coming straight out of the camera. So I can definitely tell that there is a little bit of a struggle by looking at Sadr, and the bright star there is blown out. And then we've got the nebulosity in the background, but it's overall a pretty nice looking image. For a device at this price point, this is an excellent result. If this were my first time doing astrophotography, I would be so excited. It's of course not an A-pod. It's by no means going to get you the Astro bin image of the day, but it's definitely pretty exciting to see what's possible with Dwarf Lab 3. And given more exposure time, better conditions in my night sky, and just a little bit more calibration using dark frames and some other techniques, I could probably get a lot more out of this in time. There's definitely some dark nebula in there, some emission nebula, that's the pink stuff. Dark nebula is the dark stuff. And then all of those background stars are very pinpoint, so I think the tracking was going fairly well throughout the process. And it's a great image overall. One of the things I wanted to try out here, I was having some difficulty with, was at the end of the night when I want to power everything down, I'm having trouble getting the telescope to actually fold away the optics. So the optics should be facing downward to protect them, and it wasn't doing that automatically. Now, from my discussions with the folks at Dwarf Lab, supposedly I'm supposed to be able to go into settings here, and as I go to my device and I click to shut it down, it should automatically shut down and fold away the optics, which it is now doing. So I don't know if that was part of the update or not, but it appears that it now has done what it's supposed to do, and it shuts down and hides the optics away at the end of the evening. I am noticing though, notice how the bottom here is still rotated. So that is something that I also noticed, is not only do the optics rotate down, or supposed to rotate down, but it should also make that flat. And the fact that that is not flat means that it won't pack correctly. And I don't want to just manually push it. So now I have to restart this in order to get it to turn manually so that it lines up with this to be placed into the container to keep it safe. So what we call this is the home position, and so it's not doing a very great job at homing itself back to that original position that it should be in for storage and transportation. All right, here in the photo mode, I can actually steer it manually, and I can get it to go back to its original position. Now, if you go too far in the one position, it's got a hard stop. So that's what I just saw happen there. I feel like this is something that should be automatic and should just work. When you shut down the device, not only should it hide the optics, it should also go back to its correct azimuth position. So not only altitude, which is the up and down, but also the azimuth, that's the 360 degrees of the circle in the cardinal directions, like I'm showing right now. So this seems to be a bug. It's easily solved in software, so I'm not super worried about it, but it is a little bit annoying to have to do this at the end of the evening. And I can just feel here that we got it. Yep, it's all lined up. And now I can feel confident shutting it down properly. I will take a look at this in a little more detail in a future video where we'll look into some of the other scheduling features as well as the Mosaic mode, which is pretty cool because we can take telescopic images and we can then stitch them all together to create a wider field of view. That's pretty cool because you can still maintain the resolution of the telephoto while getting the wider field that you would need to get bigger objects. So that's it for the night. So if you like videos like this one and you'd like to see more with the Dwarf Lab 3 or other telescopes and accessories, or would like to learn more about astronomy, I'm more than happy to help you out. Please leave me a comment below if there's any questions that you have or anything you'd like me to check out with Dwarf Lab 3. And everybody have a great evening and clear skies.
If you're still watching and like videos like this one, please consider becoming a Patreon patron. Memberships start as low as $3 per month, with benefits including opportunities to ask questions of our guests. Also, please consider to like, subscribe, and share this video to help us bring the universe even closer than you think.